Okay, hello everybody. How are we doing? Can we hear me? Maybe. Always possible, always possible. Let's see. Okay, so here we are again. And let me start out with a little administrative stuff. Oh, that's not going to work. Let me change things slightly here. And that is, this week I'm here, but for the final 2 weeks I'm not going to be here, which means we're going to be having classes online. So all the classes starting next week will be on Zoom. They will be on the regular class time. There's a link here. You don't have to write the link down. This will be posted on Brightspace, so you can just click on it and all. And you'll get an email as well about this. So Friday is our last in-person class, and then the final 2 weeks are virtual. Right? Now, they'll be at the same time as regular class. Can someone get the door at the back as well? They'll be at the same time as regular class, and I know not everyone is able to be at a computer at that time, so they will definitely be recorded. I'm going to be recording it in 3 different ways, so hopefully things work out with the recordings, but they will be recorded. Like this, I can guarantee. Like if a recording doesn't work, I will do the class again on my own and get you a recording, right, so that you can count on that. Unlike the recording so far, right, which is or hit or miss. Questions about that? Okay. So where were we? This, we're here. So we were doing this new model, right? And the thing we were adding to our story was this investment term. So we have this story where people make price predictions in order to set these short-term contracts so that they lock themselves into a wage. And then we see that price prediction errors can affect output. And people try to predict the central bank as well. People try to predict policymakers. So the only way policymakers can affect output is by having better or more recent information than people did when they had their thing. So we did the whole model, this exact model, without the green bit, and monetary policy, that is our gamma here, our policy choice variable gamma, doesn't affect output in any way. It affects prices, but it doesn't affect output. But now we're adding this new story, or rather this old story, the story that you had in principles, which is if you see the future is bright, you think you're going to be promoted, you're going to have a great job, you'll spend now. There's no need to save up. Or if you think the future is bright and business conditions are going to be good in the future, the price of your product is going to be higher in the future than it is now, then you're going to invest. So if you think prices are going up, you're going to invest now, and you're going to spend now. You can also think about things are cheaper now, they're going to be more expensive in the future, you might as well be spending now. Right? So that's a different story, and we're working through that in the math, and we're sort of halfway through, 3/4 of the way through working through that in the math. And what we did is we said, okay, let's take all of this. Our problem with this is we solved it the same way we always do, same way. You have one of these for your tutorials this round, by the way, something with this kind of thing going on in it. And same way we always do, say the problem with this is these price predictions. What is a rational expectations of prices tomorrow given today's information? What is rational expectations of today's prices 1 period ago when we were setting our wages? What are rational expectations of these things? And we're going to do that. So our whole problem is finding those expectations. That is, in fact, the whole subject of the course. Right? So how do we do that? We say the expectations have to be consistent with this model. So they have to be consistent with everything going on in this story, because that's how the world works for those guys. So we put all of these things together and just figured out how prices work in this model. Right? So we figured that out. And we gave it a name. We put all the equations together. We said that prices are going to behave in this way. Right? And then we say, well, solving that might be hard. And in fact, this one is fairly hard because of these forward-looking prices. It becomes technically more challenging to do, but we can guess and verify, and that will work just fine. The same technique we've been using up till now will continue to work. It doesn't become any harder. It is the same thing that we've been doing before. So we say, let's make a guess, and we see here we have today's shock and yesterday's shock are showing up here. A bunch of price prediction goofiness, but today's shock and yesterday's shock. So let's assume that our real price process, once we got rid of the expectations, will depend on today's shock and yesterday's shock. Right? Another way to think about this is all the stuff that people are making price predictions in time, if we can get this to work, in time t minus 1, and they're making predictions in time t. And so this is all the stuff that's known in t minus 1 and in t and anything that came after. Nothing came after, obviously, but after t. But all that stuff. So either way, he's going to give us the same guess as before. And as before, if we guess wrong, the math will tell us pretty directly. So it's not too stressful to guess wrong. But I find that people don't guess wrong. Like once you've gone through and done the tutorial assignments, all 3 of them, I don't find that people are guessing wrong. But even if you do, it's not a big deal. The math will tell you. Okay, so we made that guess. And given that guess, if this guess is correct, we can now solve for these things, given that the guess is correct. So we did that, and we solved for those things, and then we plug them back in. Right, so we got this one, and we got this one. We got both of these things. And if the guess is correct, that's what they look like. And here, by the way, is where I made an algebra mistake. I've corrected it on this sheet now, but I've also corrected on the sheet uploaded. Simple algebra mistake. I wrote this down as positive when in fact it's negative, and then that carried through. Right? It doesn't really change much, but you carry it through. This becomes negative. It used to be positive. This becomes negative. It used to be positive. This becomes positive. It used to be negative. This becomes negative. It used to be positive. And then at this step, we can draw on this thing. At this step, divide by 1 minus theta. To go from here to here, we had to divide by 1 minus theta, right? And that is an important step because remember, what we're doing is we're using math to force ourselves to think logically about the problem. So any legal math thing that we want to do, math is very logical language, it will be logical thinking about our problem. And that's the beauty of it. But any illegal math thing is going to be not logically thinking, right? And so here we divide by 1 minus theta, and that's all well and good as long as 1 minus theta is not 0. So at this stage, with the correct math, we need theta 2 cannot be equal to 1. Because if theta 2 was equal to 1, we would be dividing by 0, not something you can do. Okay? So if a person, just to take something sort of totally out of context, unrelated to your life, but suppose a person was solving one of these Fisher-Gray style models, say on an exam in 4 weeks, right? Which you guys will be. There will be, for sure, one of these questions on the exam. You can count on it, just like in the tutorials. It'll be different from what you've seen, but it will be the same basic stuff, right? It'll be different combinations of things. It won't be exactly the same as any model that you've solved so far, but you solve it in exactly the same way with exactly the same story. So you will be doing that. So if a person was, for example, taking an exam and did this step, divided by 1 minus theta 2, a really good answer would point out that that requires theta 2 not to be equal to 1. A decent answer might miss that, but a really good answer should point out that. Notice that it's not something that we can do for any theta 2. It really requires our theta 2 to be different from 1. Okay, and then we did that, and that gave us our R2. So what we're doing here at this stage is we have our guess, and we have our real thing. We plugged our guess into the real thing, and then we're looking for an R1 and an R2 so that this thing looks like our guess, right? And if we can find that, then our guess is correct. And if we can't find that, then our guess is not correct. And so when we looked at this thing, it's much more complicated than what we've had so far in this class, right? Before in this class, everything kind of looked like this. That is, R2 showed up in the R2 term, and R1 just showed up in the R1 term, and we could solve them completely separate. But that's not true anymore, right? It's true here. This is going to be our R2 in our guess. And that just has R2 in it, so we could solve it just like we did. But this one has both R1 and R2 in it. And this has to be equal to R1 for our guess to be correct, right? Which means that we have to solve these two things together. These are not two independent equations. They have to be solved in combination. Now, it's not too bad because we can solve this one on its own and then plug that into here. So that's fine, but we have to solve them together. And in principle, we could maybe have to just solve them simultaneously to begin with, and we couldn't solve any one without the other one. That's perfectly fine. We're just looking for an R1 and an R2 so that R1 is equal to this thing, and R2 is equal to that thing. Right? And if we can find them, whatever algebra techniques we've got, great. And we started with this one because it didn't depend on R1, so it's particularly easy. We just said R2 has to be equal to this thing. We set them equal and solve for R2. Okay. Now we want to solve for R1. Right. And so if I go down here, if I have space. This is unfortunate. Let me, next class. That is Wednesday, whatever the date is. What is the date anyway? No, nobody knows. It's a mystery. Wednesday, next class. That's all you need to know for that. Let's see if I can. Equals that, and we already found that R2 is equal to minus gamma over 1 minus theta 2. So that's what we've got. And so now we need to just see if we can find an R1 equal to this. Yeah, that's what we're looking for. And so to do that, we just take R1, and it should be equal to 1 minus theta 1 R1 minus theta 2 R2 minus R1. Right. And so I just want to put all the R1 terms together. And I already know what R2 is, so I can substitute it in whenever I want. But I'm going to wait to substitute it in so I don't have to carry around all that messiness. So I'm just going to leave it as R2 for a minute so that I don't have to carry around so much, right? Because R2 is this kind of unpleasant thing. And so it's easier just to leave it as R2 for a minute. So let me just write this thing out. R1 is equal to 1 minus theta 1 R1 minus theta 2 R2 plus theta 2 R1. I'm going to take all the R1 terms to the left-hand side. So I got R1 plus theta 1 R1 from here and minus theta 2 R1 from here. And that has to equal to minus theta 2 R2. Okay? And so I'm going to combine terms, and I'm going to plug in what R2 is. Right? So R2 is this thing, so I'm going to plug that in for R2. And the other terms on the left-hand side I'm going to combine. So I have one, it's going to be a bunch of stuff times R1. So I got 1 R1 here. I've got plus theta 1 R1 here, and I've got minus theta 2 R1 here. And that has to equal minus theta 2 times R2, which is this stuff up here, which is minus gamma over 1 minus theta 2, like so. And now, sorry, I factored out this R1, like so. So now I'm going to solve for R1, which means dividing both sides by this. And what do we know? We already found, so I can't be dividing by 0, right? If I'm dividing by 0, that's an illegal operation. I can divide by anything else I like. So we need 1 plus theta 1 minus theta 2 cannot be equal to 0 for us to do this division. Right? And what do we know? We know from before that theta 2 is not equal to 1. So we get 1 minus theta 2 plus theta 1 cannot be equal to 0. And we know that this is not 0. And we know that this is positive by the problem, but we don't know whether theta 2 is bigger or less than 0. So we also need to assume that, let me write it this way, theta 2 minus theta 1 is not equal to 1. Right? Because if they're not equal to 1, then this is not equal to 0. And from before, we needed, that's very sad, theta 2 not equal to 1. So these are the two things that we need in order for our solution to make sense. Okay. Typically, what happens if these things are not met is that you have an infinite number of solutions. There's many, many, many solutions. But we don't have a proof for that here. We only be able to say, using our guess and verify method, that we couldn't find a solution. Okay. Maybe there's a million of them, maybe there's none. We wouldn't know. We would have to use more, well, I don't want to say advanced, I don't want to say difficult, more involved methods to do that, right? Which would take half the semester to teach, so we're not doing it. But not particularly undoable either, but we just don't know using the guess and verify method. And that is one of the big disadvantages of the guess and verify method. Right? Typically you can find, here's a solution. You're never sure whether that's the only solution. If you're unable to find a solution, you don't know whether there's millions of solutions or you just couldn't find it using your guess. You just don't know those things, right? So we get a solution, and I'm telling you for the problems that we've been solving, it would be sort of the base of a class of solutions, and it would be the solution that people would mostly use in the literature. So we're getting the real answer, but you got to a little bit take it on faith because we didn't prove that to you. Okay, so noting this kind of thing would be, your difference between a very good answer and a great answer would be noting these things, and right, it's not crucial. So get through the class, but why not pick up the points when you're there, right? So make sure that you're doing legal mathematical things, and the illegal mathematical thing that you're most likely to do is dividing by 0, right? So make sure whenever you're doing a division, say, look, we need the parameters in such a way that we're not dividing by 0. All right, so assuming that's true, we can divide by that thing. And on the right-hand side, these minuses cancel out. So the right-hand side is going to be equal to, let me just write it, R1 is equal to 1 over 1 plus theta 1 minus theta 2 times gamma theta 2 over 1 minus theta 2. And let me just check and make sure it matches the notes, because algebra being the way it is. Yeah, look at that. Look at that. That's beautiful. Right? Is that right? Did I drop a 1? Yes, I dropped a 1. Notice when we went to this step, there was this 1 here. So that 1 has to show up there. I'm glad I checked the notes. We got a 1 like that. So this whole thing becomes, erase this, 1 plus gamma theta 2 over 1 minus theta 2. There we go. And now here's a useful thing to say about exams, because I know exams are coming up and people are stressed about exams. You can see anyone can make an algebra mistake at any time, right? I am particularly prone to algebra mistakes, but of course in an exam situation you're on a time limit, you're stressed, of course you can make an algebra mistake, right? And in fact, algebra mistakes are not horrible, right? If it's clear that it's an algebra mistake. And so what this means is that it really, really helps to show your work, right? Because if you're getting a wrong answer, it's important that we know why you're getting a wrong answer. Are you getting a wrong answer because you didn't understand what you're trying to do? Or are you getting a wrong answer because you made an algebra mistake? If it's an algebra mistake, don't care, you can get full points. A minor algebra mistake, sign error, something gets dropped going from one line to another, happens to you, happens to me, happens to all of us. But it is important that we know, right? So if you're just putting down answers, we have no idea whether you understand what you're doing. And so you get graded off, and can get graded off pretty heavily just because you made an algebra mistake, because we don't know that it's just an algebra mistake. But if you're showing your work, then we say, okay, here's what happened on this line, you just dropped this thing. It is absolutely not a big deal. Okay? Then, though, if you make an algebra mistake, sometimes it just doesn't matter and it comes out, you just get a wrong answer, but it's sensible and normal, and then that's just fine. Okay? Sometimes you make an algebra mistake and you just cannot proceed. Okay? In that case, that's not great, right? Ideally, you would go back and say, okay, I'm just not able to proceed, let me check my math. And you'll have some time on the exam. It's not super time-pressured exam, but it is a limit, right? It's a 2-hour limit. And so you might not be able to find your error. If you're in that situation and you say, okay, I really think there's an error there, it really is helpful if you say, look, this answer is not coming out sensible. I believe there's an error somewhere. I cannot find it on the time limit, but I believe there's a problem, and here's why I think there's a problem. That can actually be a really good answer. If you're coming up and you're getting results that make no sense economically, and you say, these results don't make sense economically. Here's what I got mathematically. My intuition is this. It's not matching. I am concerned that I made an algebra mistake somewhere. That is actually a great answer. Okay, so it's not a math class. It's not an algebra class. It's an economics class that uses math to think logically about things. We're totally aware that algebra mistakes can and do happen. They can happen to me, they can happen to you. It's a bit, how it goes on the day. But keep your brain on, right? And look at your answers. Are your answers sensible? Are they making sense in terms of what you know about how these models work? There is not going to be a trick question. Obviously, it's going to be a new question, but it's not intended to, you're going to discover a new intuition that you never had before. No, it's going to be the same intuition that we've had in class. If it's not matching that, that's telling you probably there's an error somewhere. And if you say, I think there's an error somewhere, and you say why you think there's an error somewhere, that's a great answer. Okay? Particularly if you were going about solving the problem right, and you just made an algebra mistake. Clearly, if you get a wrong answer because you just went off and on the deep end and did totally wrong things, That's different. You're supposed to know how to solve the problem, but an algebra error shouldn't get you, right? Assuming you're letting us know enough information so that we can see that you know that it's an error. If it shows, like sometimes you do an error and it doesn't show, you would never know, that's absolutely fine too. Show your work, that way we can figure out where. Like what we typically do is we say, okay, are they doing the problem, are they doing the right steps? Is the answer right? Then that's easy. And then you just look at, okay, do they have the intuition? Do they understand what the answer means? But sometimes you say, okay, they seem to be doing everything right. And then you look at the answer and the answer is just wrong. You say, okay, let's go back and figure out where they made a mistake. Right? And if they made a mistake and because, oh no, they weren't doing everything right, they really misunderstood what they're trying to do, that's a problem. But if you go back and you say, okay, it's somewhere in this step and it's really, they understood what they were trying to do, but they just made a mistake, that's still like a perfect score. Right? There's absolutely nothing wrong with that answer. Right? It is about the economics and understanding the method. It's not about did you keep every minus. Life is easier if you do your algebra right. I always prefer doing my algebra right, but it happens and it's fine. Okay? Don't freak out about that. Just go on to the intuition and explain what you expected to see, explain why it's different from what you saw. I say, I don't understand this. I think I might have made a mistake. That's actually a decent answer. Getting an answer that's clearly wrong and not knowing that it's clearly wrong, that's a problem. Right? But getting an answer that's clearly wrong and understanding that it's clearly wrong, that's what we're looking for, actually. Like, we want people with their brains on. Okay, that's my little rant about math. Okay, so we've got these things. Now we've got R1 and we've got R2, right? R1, it's all in terms of parameters. We found it assuming these things are true. We have found an R1 and an R2 so that our guess is equal to what we actually get. So the real thing and the guess are consistent with each other. These form rational expectations of prices. And remember, the guess was PT is equal to R1 ET plus R2 ET minus 1. Right, so I'll put it down here again. R2 is equal to minus gamma over 1 minus theta 2. Right. And so now we know that the true process is, I'm not going to write it out because this is a mess, as you may have noticed, but the true process is this thing times ET, the shock in time t, plus this thing times ET minus 1. Okay? And that's the true process. Okay? And you'll notice gamma shows up in both of them. And so, unsurprisingly, just like always, monetary policy can affect prices. If you print more money, there's bound to be more higher prices. But that's not what we're really interested in. We're interested in is, can we affect anything real? Can we affect the business cycle? So we want to go back and find why. Right? And if I can do that, let me copy and paste them. So we have, if I can, back down to the end. We got that. And we have two more things, which were the price. Like when we look in, when we look in this thing, what y is, it depends on these two price errors, right? This one's an error, and this one is expected future prices. Do we expect prices to go up and down? It depends on how these things, right? And we have found, we could go back and like, now that we know the true process, we could find these things again, but actually we did that already. And so we can jump to the right answer if we go up here, and 77 and 78. Well, we named them because we knew we were going to come back to them. We have this one, which we can put down here. 78, which we saved as well. Find it. Here it is. So we've got those two things. So now we know what R1 is, we know what R2 is, and rather than finding these expectations all again, we found that our guess is correct with our R1 and R2. So we can plug these things in to here and find what Y is. Now, it's a little unpleasant because R1 is so unpleasant, right? But we can do it. Like it's just a matter of plugging things in. So that's what I'm going to do. I'm going to find yt minus y bar is equal to theta 1 times pt minus pt given t minus 1. That is 77. So 77 is R1 ET plus theta 2 times this thing, which is 78, which is R2 minus R1 ET minus R2 ET minus 1. Okay. And our R1 is a little unpleasant, so we're just going to have to sort of push through this. Right? I will say, by the way, that this is more algebra intensive than I would give you for an exam because there's just more places to make a mistake, right? So these are going to look messy. We're going to plug through them. We are just cramming the algebra through here. But for what you're expected to do on the exam, like you should be able to do this, but I wouldn't ask it this question just because there's too many places to make a dumb algebra mistake, which is useless. It's not what we're trying to test. So we don't want to test your algebra skills. We want to test your understanding of rational expectations, right? And so it'll be a simpler model that captures some of the same ideas, perhaps. So in terms of complexity, the stuff that you've been getting for the tutorials, this week's tutorial, this round of tutorials and the previous two, that's the kind of complexity of algebra that you should be expecting for the exam. Okay. But we can do it. We know what R1 is. We know what R2 is. We can just plug these things in. So I am going to do that to the best of my ability. And I would very much encourage you to yell out, "You've made a mistake," when I make a mistake, so that would be great. Okay, so here we are. We're going to do this thing. So we get yt minus y bar is equal to theta 1 times R1. R1 is this unpleasant thing, 1 over 1 plus theta 1 minus theta 2 times 1 plus gamma theta 2 over 1 minus theta 2. That's R1, and that's times ET. Okay. Plus theta 2 times a whole lot of unpleasantness. We got this R2 minus R1. So I'm going to have R2 minus R1. R2 is minus gamma over 1 minus theta 2. Okay, that's R2. And let me, minus R1, so that's going to be minus 1 over 1 plus theta 1 minus theta 2, 1 plus gamma theta 2 over 1 minus theta 2. All of this unpleasantness times ET. Minus, then we have this bit here. So that's going to be minus R1, R2. So that's going to be plus gamma over minus theta 2 et minus 1. Okay, so there's all our unpleasantness. Let's see how much I want to simplify this. I think I don't much want to simplify this. I'm just going to put all the ET terms together and all the ET minus 1 terms together. Right, so this is going to be yt minus y bar is equal to. So here, I've got ET is showing up here and here. And this whole thing here is R1. This whole thing here is R1. So what do I have? I've got this bit here. I've got minus gamma theta 2 over 1 minus theta 2. This is all going to be times ET. Right. That is this bit here. And then I've got theta 1 times R1, and then minus theta 2 times R1. So this is going to be plus theta 1 minus theta 2. Erase this. And R1 is a bunch of unpleasantness. It is 1 over 1 plus theta 1 minus theta 2. 1 plus gamma theta 2 over 1 minus theta 2, like so. All of that times ET. And then we have the ET minus 1 bits, which are much easier. It is just plus gamma theta 2 over 1 minus theta 2 ET minus 1. Okay, that's some unpleasantness, but there we go. It's a solution. Yay, team. No? Are we not happy with ourselves? No, not really. We say, look at this thing, we say, oh, what the hell is this? Do we not say that? I believe we do. And so we need to step back and say, okay, clearly, possibly, this could be simplified in some way. We got minus gamma theta over 2. Possibly we could simplify things, but in fact, at this stage, we probably don't need to. What we need to do is we need to go back and we need to think, what are we doing this for? What is this all about? Why the hell, right? What we're wondering is, can the central bank, through its policy, which is gamma, the gamma term, can it affect output? Okay? And clearly, it can, right? It can affect output through here, for instance. We don't know about this. This is a nightmarish hellscape. But through this, it clearly could affect output. Which it couldn't, by the way, before. Before we added in that investment term, it was unable to affect output in any way. It could affect prices, but it could not. So clearly all this is coming about because we've added that new term in. And we can see that because that new term has theta 2 in it. And you'll notice theta 2 is multiplying by gamma here. And it's in other place where gamma shows up, it's also multiplied by theta 2. Right? So clearly, this is all about the second term. Right? For two reasons. One, we see the theta 2 in there, and that was the second term in our y equation, our investment term. And also because when we solved it without this, there was no gamma. Right? So gamma didn't show up. You couldn't affect output in any way. So clearly here you can affect output, and it's because of this investment term. Okay? It is not because of the price prediction errors that we had before. It is because of this forward-looking investment. Okay? So what the heck is going on with that? Okay? So the way I want to think about this is we could like stare at it. We could take derivatives of this thing and find the slope and that kind of thing. But I think it's probably more instructive to think of some extreme cases. This is our solution. We could simplify it, but we're going to leave it that way. Right? I don't know how to spell extreme cases. Extreme case, for example, we could have gamma equal to 0, no monetary policy. If we did that and the central bank just didn't do anything at all, just left its money supply the same, that is gamma equal to 0, we would get yt minus y bar is equal to, this bit here would be 0, this bit here would be 1, so we would get theta 1 minus theta 2 over 1 plus theta 1 minus theta 2 times 1 here, the gamma bit times ET. And that would be output. Okay. And you notice if theta 2 is 0, that's the model we had before, and output is theta 1 over 1 plus theta 1. And now we got this theta 2 thing going on here. So with passive monetary policy now, there's this element of theta 2 affecting things. So we're reacting output, velocity depends on the current shock. That's why the current shock matters, because it affects velocity. Right? So if people are spending their money really quick, prices go up. If people are spending, so if the shock is large, prices go up, even without monetary policy, because people are spending their money really quickly. They're spending their money really quickly, prices go up. What does that mean? Well, that means, first of all, prices are higher than what people expected them to be when they set their wages. That's the theta 1 term, our traditional term, right? And so the prices are higher than when they set their wages, the real wage is low, they hire lots of workers. So when the shock is positive, theta 1 makes output go up. That's this bit here, theta 1. Right? Theta 1, because we have a positive shock, velocity is high, therefore prices are high, therefore we produce more stuff, real wages are low. Okay? That's our price prediction error. Lovely. But we also got this second thing going on. So what's that? Well, we have a positive shock. Velocity is high. People are spending their money really quickly. So prices are high this period. But next period, we don't know what the shock is going to be. So what it means is that because prices are high in this period, it is very likely that prices will be lower next period. So we go back up here to our original thing. Right? This is the original assumption. See, the investment depends on, do we expect prices tomorrow to be higher than prices today? Right? And we don't know anything about tomorrow because this shock is IID and that's all that matters. But if we know today's prices are very high, and they don't affect tomorrow's prices, that means we expect prices to fall. And we expect prices to fall, meaning we expect bad times tomorrow. We're not going to buy stuff now. We're not going to invest now. There's no point building a factory now because you're building this factory at these high prices and you're only going to be selling your goods at this low price. So you cut back on investment. Okay? Which is why what we got here, we go scroll back down, is negative with respect to theta 2. That is, when we have a positive shock, theta 2 makes output go down. We have a positive shock, means we're spending our money really quickly, therefore prices are high. That means they're higher than what we expected, real wages low, people work more. That's theta 1. But prices are high, so we're expecting prices to revert back to normal next period, and so we expect prices to go down. Everyone cuts back on their investment, and that's the theta 2 bit. Okay. Okay, I'm gonna finish this next time. I think it's better to not rush it. because you notice it's a little complicated looking. And so the how theta 2 works, we're going to talk about next time. How monetary policy works, we'll talk about next time. And see you on Friday. Once again, in person on Friday, virtual after that.